Welcome back, zoologists, for Mollusk Lecture Part 2. So in this part of the lecture, we're going to talk about we're just going to talk about three examples, three classes within the Mollusca as examples of the diversity that exists within the entire phylum. This is a picture from your book of the various classes of mollusks that they cover anyway. Most of these we're not going to cover. Some of these are very old. And they're very unique. We're only going to cover three classes. The gastropoda, these are your typical sort of snails and slugs. The bivalvia, so these are things with two shells, so oysters, clams, mussels, those kinds of things. And the cephalopoda, probably the most extreme class within the mollusca, the most intelligent, the ones with the most highly developed nervous systems, and capable of extreme camouflage and skin texture changes, among other things. So we're not going to cover the rest of these, although you will see examples of these in lab, and they'll go over more of the classes in lab. Okay, so I got rid of the other classes in this phylogeny, and these are the ones that we're going to be focusing on. So let's start with the bivalvia. So they're called bivalvia, again, because they have two shells or two valves that they open up. So clams, mussels, oysters are all included in this group. By definition, they're characterized by possessing two shells, and they have special adductor muscles that allow them to open and close these shells. We talked earlier about the radula, the structure that is used by many mollusks for rasping out their food. So in these guys, the radula is lost. These are generally filter feeders or suspension feeders. If you look at their anatomy, and you're going to see these guys in lab up close and personal, this is that stylized diagram I showed you before where one of the shells is removed, and you're seeing the mantle, and then here are the gills. The mantle, this is the mantle that's on the bottom shell as it's depicted in this picture, and then here's the foot. So what they do is, this is the head region, food will go in through here, and then there's a current of water that is pulled in through this part of the individual, and then the flows across the gills. And so when they feed, what's happening is there's a mucus layer that's produced on these gills, and even though these are primarily, or are in part used for respiration, the mucus layer allows for the trapping of particulate matter. And then that particulate matter is moved by ciliary action towards the mouth and is consumed and then goes into the gut. So what's important to note here is that these gills are used for respiration, they're used for feeding, and later we'll talk about reproduction. So in some individuals, or in some species rather, the young are actually held on, or kept on top of these gills until they reach a particular stage of development, and then they're released. And we're actually going to talk about that in detail during lecture in class. So I say here again, gills are used for respiration, feeding, and reproduction. Going back to that head, foot, and then the mantle aspect of mollusks. So here you're seeing, in the case of the bivalves, there's a huge reduction in the head part of this, right? So they don't have the kind of cephalization that you see in other taxa. In fact, they really don't have a brain at all. They barely have ganglia. It's hard to believe that these are species or a class that's closely related to the cephalopods. They do have a well-developed foot, however, and to sort of show you just how adept these things are, I'll show you a video here. So here's a clam on the beach. And here you can see the foot being exuded. And you can see it's quite adept at actually digging into the sand, and quite rapidly as well. And they can bury themselves with great facility. All right, there you have it. Going back to the lecture, Now, as it happens, they have quite a number of adaptations where a number of freshwater species have modifications of that foot structure that they use for lures. And I'll show you some videos in class where they've modified these for reproductive purposes, where they can actually lure in host fish species that they will then use for their young, for their Glaucidia to latch onto their gills, but I'll show you that in class. So we already noted that these guys have a circulatory system that's pumped by a heart. It's a very simplified heart. It's 3-chambered, but it's not like yours, and I'm going to show you more images of this in class. It doesn't have auricles and ventricles like ours has. It's a little different. And in these guys, in the bivalvia, it's an open circulatory system, and I showed you an image of this in the last podcast, but just to kind of orient you, it's here. And don't forget that the coelomic cavity is substantially reduced and only occurs right around the heart in the bivalvia. And actually it's substantially reduced in all the mollusca. So they do have ganglia, but it's a poorly developed nervous system, which makes what I'm going to tell you about in class regarding reproduction all the more amazing. Most species are dioecious, so you have separate sexes. There's external fertilization, so usually the males are releasing their sperm into the water column and the females take that sperm up, fertilizes their eggs, and then those fertilized eggs are held onto their gills until they reach a certain stage of development. They may have either a trochophore larvae or a veliger larvae. Some species have Glaucidia, and I'll show you this video in class. Okay, now let's talk about the gastropoda. So it's important to note, by the way, that of these 3 classes that we're covering, the gastropoda and the bivalvia are sister taxa, and they are more closely related to each other than each is to the cephalopoda. So the gastropoda are the typical sort of snails and slugs. You can see images here. They tend to have one shell, if they have a shell at all. Some lack the shell. Their shells can be swirled or curved around, but in a number of different ways. So you can see some images of that here, and I'll show you more images in class of how the shell can be coiled around. So if the shell is present, it will exhibit torsion, and this is a concept that we'll go over in class in more detail, but let me try to explain it to you at least briefly here. So these are images from your book, and I'm going to walk you through each of these stages of development. So what you're seeing here is sort of a lateral view of a developing young Glaucidia, let's say, for a bivalve, and this is sort of a dorsal view. So what you're seeing here is, again, the young. This is the shell here. Here's the mouth, and what's meant to be a stylized view of the gut, and then here's the anus. Here's the foot, and when they're young, they have these what are called velar lobes. Okay, they use these for swimming as well as for respiration, and to facilitate food capture as well. So when you see the gut here, you can see it sort of makes a U shape from the side. If you're looking from the top, it just goes from front to back. But what happens over time is, as the shell develops, the internal organs twist around. And so that's what's meant by torsion. So basically there's a coiling of the internal anatomy. So you can begin to see this here. So again, here's the mouth, here's the anus. Notice here, as it's beginning to twist, the mouth and the anus are coming in closer contact. And you can begin to see the twist from the dorsal view here. As development continues, you have more twisting of the internal anatomy within the shell. Here you can see the mouth and anus are becoming quite close to each other, and this is an even better view. This dorsal view shows how the anus is coming around. And then just before it becomes mature, there is substantial coiling here. And you can see it in greater detail here. So twisting, twisting, twisting until you almost get a full 360. And then here's the adult stylized snail. And so what you can see is here's the mouth. As you go through the gut system, the internal anatomy, it twists around in the shell, and then here is where the waste would be deposited, right over the head. and you can get an even closer sense of it here. So all gastropods exhibit torsion, and as it happens, cephalopods exhibit torsion as well, and I'll show you this in just a moment. So this is a very interesting situation, and it has some implications to the organism. So as you can see here, when they excrete their digestive waste, they're going to be excreted right above the head region. And clearly this is not adaptive. It could foul the environment for the snail or the slug or the individual, and could be fatal if it continues to occur and there's no fresh water to pull away the waste products. As it happens, all of the gastropods and even the cephalopods that exhibit torsion have ways to overcome this problem of fouling. And actually, I have an image of this in just a moment, a slide down. But suffice it to say that if you live in water, usually you're going to be in a current that will wash away those waste products. And so, by virtue of living in water, you're going to be saved from this maladaptive feature. In the case of some snails and shells, in the case of some snails, they actually have a groove on their shell that helps to direct the waste products off to the side of the head rather than directly over the head, so they're unlikely to foul them as badly as they could without that groove. Okay, so the shell can be coiled in a number of ways. In this case, we're looking at it being coiled off to the side as opposed to directly on top of itself, kind of like a nautilus does, and I'll show you an image of that in just a moment. What I want you to notice from this stylized cartoon is the development of the digestive tract. So notice that the food goes into the mouth. In this case, they're showing you the radula. Here's the stomach. You go into the intestine, and you're starting to see greater development of the internal organs, digestive organs. Here's the stomach here. By the way, let me point out the kidney. So remember, these guys have a slightly more advanced protonephridium. Here's the heart. You can also see further coils. All of these coils, the intestine well up into the shell, the digestive gland, and this is actually the precursor to the liver. So it's not a true liver yet, but you're going to see this develop into a liver in subsequent taxa that we're going to cover. You're starting to see the albumin gland, so this is what's going to secrete the shell. You can also see a pretty well-developed circulatory system, unlike what we've seen previous to this. And you can see some of the reproductive organs as well, so both the spermathecal duct, the seminal receptacle, and the dart sac. So I'm going to show you some videos in class for the reproduction within the gastropoda. They do some really fun and interesting things. Some of them actually shoot out sperm darts, and they jab them into each other's bodies to fertilize the eggs. Seems pretty harsh. By the way, also note the ganglia here, and what's the stylized representation of the nervous system. So these guys don't have as well developed a sensory system as the cephalopoda, but it's certainly far advanced over the bivalvia. And of course, they're well known for having eyes and eye stalks, and here are their tentacles. And so they actually have quite good sensory perception, both chemosensation and tactile. And I already showed you a video of how the foot works in snails. So feeding varies. Most do use the radula. There are a few species that don't. They respire with gills, but they can respire through their skin as well. So depending on the species of gastropod you're talking about, they might have 1 or 2 gills, or they might have 0 gills. They have the single nephridium seen here. Circulatory and nervous systems are well developed. They can be dioecious. Some species are, so they have separate sexes, or many are hermaphroditic. And if they're hermaphroditic, they're generally simultaneous hermaphrodites, not sequential. They have internal fertilization, and they lay eggs. They're oviparous. Okay, and then let's briefly go over the cephalopoda. I'll talk about these guys more in class and show you some videos of some of the amazing feats that they can do. The cephalopoda includes examples like the octopus, squids, cuttlefish, and nautili. In these guys, they have a really interesting morphology where the head and foot become indistinguishable. Basically, they're right on top of each other. You're going to see this is a typical sort of orientation where the body is coiled up in here. You'll see some torsion. The head foot is here, and then lots of tentacles. And of course, depending on the species that you're talking about, you'll have a variety of different arrangements and size and shapes of the oral arms versus the tentacles. So bear in mind, by the way, in this stylized diagram, these are the oral arms, and these are the tentacles. So they have two completely different functions for the organisms. You're going to see this in lab in great detail as well. So they feed on literally everything, anything they can get in their mouths, and they have really strong beaks. So let me cover this material first, and then I'll show you a couple of images of their beaks. So what you want to notice is, here's the mouth. By the way, here's the radula in this particular diagram. The food's going to go in through the mouth, up through this duct, all the way up to the stomach, which is up here, and what might be considered the top of the head. And notice the torsion that's exhibited here. So it goes up into the stomach, and then into the cecum, and then back down the gut, and then it'll exit here out the funnel valve. And notice, very much like with the gastropods, here's the head and mouth, here's the exit, here's the anus, right? So it's right over the head. But since these guys are really active predators and they're swimming around all the time in the water column, they're unlikely to foul themselves. The water's going to pull all those wastes away. But notice too, the digestive gland here, here's the kidney, here's the gonads, and then here's the heart. And then you'll also see the gills as well. And you'll see all these structures in lab. Notice that there's no obvious shell, even though, as it happens, most cephalopods either have a reduced shell that's known as a pen. You can see it here, and it's sort of a rigid structure that's in one part of the main body or trunk of the body. In some cases, it's true that cephalopods have largely lost the mantle. And then in things like Nautilus, you have a quite extensive shell. So there's quite a bit of variation within the cephalopods on the presence of the shell and mantle. Oh, the beaks. I was going to tell you about the beaks. So if you look in the mouth of cephalopods, they have an outrageous looking mouth structure right here. It almost looks like an eagle's beak. Here's a close-up. My understanding is these things are pretty harsh. You don't want to stick your finger in there because it'll chop your finger right off. So be very careful. But you can see how if they're grabbing any prey items, chances are that prey item is going to lose if it gets a hold of it and puts it in its mouth. Okay, so most lack the external shells, but it's been reduced into a pen. Remember, of the mollusca, these guys have a closed circulatory system, and that's usually characteristic of highly active organisms. And they do have gills, but they can respire through their skin as well. They have an extremely well-developed nervous system, and I'll show you examples of this in class. They're dioecious. They exhibit internal fertilization, but they do lay eggs. They're oviparous. And they exhibit all kinds of amazing color changes. We'll look at how well they can camouflage themselves, despite the fact that they have very good vision, but it's not color vision, which makes their color changes all the more amazing. Now here's an example of some of these cephalopods. So these are cuttlefish here. Here's the classic octopus, and this is the nautilus. Notice it's really extensive shell, very much like the gastropods. But notice in this case they have these compartments here. So these compartments are laid down on a regular basis, not unlike tree rings, but different of course. So these are referred to as septa, and they're only living in the most recent compartment of their shell. They exhibit the same sort of anatomical morphology that you see in octopi, but it's sort of scrunched up into their shell, and so they exhibit quite a bit of torsion as well. Oh, and I just wanted to show you that pen that I was referring to. So this is the pen of cuttlefish, and these are often washed up on beaches, and you can purchase them in stores as well. And this is what a lot of people will feed to their birds to sort of sharpen their beaks, and in some cases gain some minerals from as well. So they're often referred to as cuttle bones. Okay, That's all I have to share with you on the second part of the mollusks. We'll talk about more of this in class.